Okay, welcome back. So in this video I'll be explaining you about another way of solution or another method of solving quadratic equations, and that is the concept of completing the squares. Now to begin about the topic of completing the squares, I'll take a simple example like this. Say if you have been given something like this, so if you have been given x squared plus 6x plus 8 is equal to 0, right? 8 is equal to 0. So if we have been given something like this, now you know one way to solve this is by the equation or the quadratic solution equation, and the next way would be to find the roots, right, through the remainder theorem, and there are many other means. But in the case of completing the squares, what you do is that you take this side to be the left side, so you know that, and you have an equal mark, and you have a right side, so this is an equation. So what you do is that you complete a square. Say you have some square x plus 1 squared or x plus 2 squared or something like that. You complete a square on the left side and you solve for the right side. Now you know that x squared plus 6x plus 8 cannot be written as a complete square. To make it a complete square, what I have to do here is that I have to make this right side as a complete square. So to do that, I have to move this 8 to this side. So my first step of solving using the method of completing squares will be like this. So I take this 8 this side, so that will become minus 8. So my left hand side will be remaining with x squared, use another color, x squared plus 6x is equal to minus 8. So my next step is to complete this square. So you know that if x plus 1, if you are given a function like x plus 1 squared, x plus 1 squared is equal to x squared plus 2 times x times 1, which is 2x, plus 1 squared, that is equal to 1. So x plus 1 squared is equal to x squared plus 2x plus 1. Similarly, if you are given only the squared term with the coefficient and the x term or x to the power 1 term with the coefficient, and you need to find the constant here to complete the square, what you do is that you divide this term by 2 and you square it and add to both sides. So that is actually the most important step in the case of completing squares. So to get the constant to complete this square, what you do is you divide this coefficient. If it is minus, you have to take it as a minus coefficient. You divide this coefficient by 2 and you get the result. You square that result and you add it to both sides. So in this case, when I divide this 6 plus 6 by 2, it will be plus 3. So when I square it, it will be plus 3 squared is plus 9. Whether you square a minus term or a plus term, it will be a plus term. So when you add both it to both sides, you will be remaining with a function like this. So x squared plus 6x, when I divide it by 2, it will be plus 3. When I square it, it will be plus 9. I have to add 9 to both sides. So I have to add 9 here, and I have to add 9 here as well, because we are adding 9 here, right, to remove the inaccuracy. If you add 9 only to one side, this equation is not equal to this one. So this is a sequence. If we add something or subtract something here, we have to do the same thing to this side as well. So you know that x squared plus 6x plus 9 is actually x plus 3 squared, x plus 3 squared, and that is equal to now minus 8 plus 9 is 9 minus 8, which is equal to 1, right? So what you do as the next step is that you take the square root of both sides. So when you take the square root of this side, the root of x plus 3 squared is x plus 3, and you have to take both the positive and the negative root of the left side, both the positive and the negative root. So that will be the root plus or minus root 1. So root 1 is 1. So that will be plus or minus 1. Now there are two occasions or two options, that is taking the positive consideration and taking the negative consideration. When I take the positive consideration, I can say that x plus 3 is equal to 1. So x is equal to minus 2. When I take the negative consideration or negative option, x plus 3 is equal to minus 1. So x is equal to minus 4. So when x is equal to minus 2 and x is equal to minus 4, in other words, x squared plus 6x plus 8 is 0. So in other words, x plus 2, when x is equal to minus 2, x plus 2 is 0. And when x is equal to minus 4, x plus 4 is 0. In other words, x plus 2 and x plus 4 are the factors of x squared plus 6x plus 8. So you know that if these two are factors, their product should be equal to that one. So x plus 2 times x plus 4 is actually x squared plus 6x plus 8. So we are doing here is like the cycle, like the carbon cycle. So you know that x plus 2 times x plus 4, when that is equal to 0, you can get x squared plus 6x plus 8 equals 0. Similarly, on the other hand, you can solve it using either completing squares or using the general equation for the solution of quadratic expressions, the formula, and you can solve it. So without using the formula, this is another step this is actually another method of solving of quadratic equations, right? Solving of quadratic equations. So if you draw this on a Cartesian axis, like this, you know that when x is equal to minus 2 and when x is equal to minus 4 is equal to 0. So I will mark minus 2 and minus 4 here. So minus 2 will be somewhere here and minus 4 will be somewhere here. I'll draw it in another color. So when x is equal to minus 2, this is a quadratic function, so you know the shape of the graph of a quadratic function is a parabola, and let's see whether this touches the y-axis. So if it touches the y-axis, you can say that when it touches the y-axis, the x coordinate is 0. So when I substitute x equals 0 in this, I can get that function goes to positive 8. So at positive 8, it touches the y-axis, or the intercept is positive 8. So the graph will be as follows. The graph, now you know that the graph should be positive because we have here, you should have a minimum graph. So the shape of the graph will be like this. I don't know the exact values. It should go through positive 8 on the y-axis, negative 2 on the y-axis, sorry, negative 2 on the x-axis, and negative 4 on the x-axis. Something like this. And it should be a minimum graph because the coefficient of the square term is a positive term, positive 1 in this case, right? So x equals minus 2 and x equals minus 4 are actually the roots, and x plus 2 and x plus 4 are the factors, and that we can take from other concepts as well. So this is all about completing square. So this is not a part of completing the square, just explain it to you. So when you are completing a square, what you do actually is that you divide the coefficient of the x term by 2 and you square it and add it to both sides, and you can solve. That's the next step to get a complete square on the left side. You solve for the right side, you take both roots, and you finally find the x values. So let's take another example to elaborate this concept. Say you have been given something like this. A function say x squared plus 7x minus 4 is equal to 0, right? X squared plus 7x minus 4 is equal to 0. So how to find the roots, or how to find the values of x in which this equation satisfies to 0, right? So I can do it again through the completing of square. So that's my intention of this video. So what I'll do at the first step, as I mentioned a little while ago, is that to complete the square of this side, I'll take this minus 4 to this side. So that will be x squared plus 7x is equal to now positive 4. So as my third step, what I'll do is I will divide this term by 2. So that will be plus 7 by 2 or 7 by 2. I'll square it. So that will be 7 by 2 squared, or 7 squared is 49, 2 squared is 4, or 7 by 2 squared is 49 by 4. So I'll add it to both sides as a third step. So that will be x squared plus 7x plus 7 by 2 squared is 49 by 4. I add it to both sides to get rid of the inaccuracy. 49 by 4. Sorry, 49 by 4. Right? 4 plus 49 by 4. So here I will get this x squared plus 7x plus 49 by 4 is actually x plus 7 by 2 whole thing squared, and that is equal to now 4 plus 49 by 4 is 4 times 4 is 16. 16 plus 49 is x 64. 64 by 4 is 16. No, sorry. It's 65 by 4, not 64 by 4. Right? 65 by 4. Pardon me. Right? So you will not get a complete answer for this. Right? But you can solve it. So you can also write, if you want to solve it through another step, you can also write 65 by 4 as 65 by 65 root 65 squared and 2 squared. So you can also write this as a complete fraction, as a squared fraction, root 65 by 2 whole thing squared, right? If you want, actually that's not necessary. If you want, you can do that. So as the final step of this, what I can do is that I have to take the square roots of both sides. So when we are taking the square root of this side, that will be x plus 7 by 2, and this side we have to take both the positive and the negative options. So x plus 7 by 2 is equal to plus or minus root 65 by 2, right? Root 65 by 2. So when I take the positive option, I will be remaining with this term, x plus 7 by 2 is equal to root 65 by 2. So x is equal to now root 65 minus 7 by 2, which is approximately equal to, root 65 is approximately equal to 8. So 8 minus 7 is 1. So 1 half is, this x is approximately equal to half. Right? X is not equal to half. X is approximately equal to half. When I take the negative root, x plus 7 by 2 is equal to minus root 65 by 2, minus root 65 by 2. So, right? So x is equal to, so you know that minus root 65 is approximately minus 8. So when I take this to this side, it will be minus 7. So minus 8 minus 7 is minus 15. That will be approximately not equal, approximately to minus 7 by 2 or minus 15 by 2 or minus 7.5. And this will be approximately equal to half or 0.5. Alright, so those are two examples about completing the square. So completing the squares is another way of finding solutions for a quadratic expression rather than through factor theorem or the remainder theorem, or through going through factoring, or going through the general solution or the general equation for the solution or the general formula for the solution. So completing squares is much easy. It requires less steps, less solutions, and it will be probably an interesting step for you in the case of finding solutions for quadratic expressions. So I finally finish the concept of the functions on algebra. So I'll meet you with another concept on algebra, and thanks for watching this video, and see you soon, and goodbye.